Hi students, this is N. Sriram, Associate Professor from Department of CSC. In this video, I am going to give a lecture on bitwise operators. Student, this is the very important topic, particularly in C programming. So let us see what is these bitwise operators, how can we use these bitwise operators in programming, and we will see some of the examples also. First we will see what are the objectives of this session. So if you take this session aim, the first thing is here we are going to learn about bit level manipulations of the data. You see students, when we are working with the computers, internally the data will be stored in the binary format, so like zeros and ones. So if you want to understand these bit level manipulations, and if you want to perform these bit level manipulations, you should know these bitwise operators. And coming to the objectives of the session is, we can understand different types of bitwise operators, we can understand the manipulation of the binary data, and then we demonstrate various types of bitwise operators available in C language. Okay, next coming to learning outcomes. At the end of the session, once you hear the session, you can perform bit level manipulations, and you should able to apply some bitwise operations, and you can efficiently manipulate the binary data. So in based on this view we start the session. So first we will see what is these bitwise operators. Here students, bitwise operators are mainly used to perform bit level manipulations. Bit level manipulations means here we are going to do some operations on binary data. Usually when we try to store some data in computer, the data stored in terms of binary. So whenever you want to perform bit level manipulations on binary data, we can use these bitwise operators. Okay, here if you want to perform these bit level manipulations, the C programming language supports 6 kinds of bitwise operators, and we will see each and every operator in detail. Here if you observe in this table, the first operator is known as bitwise AND operator. This operator is indicates with the symbol single ampersand. Next operator is a bitwise OR operator. This operator indicate with the pipe symbol. The next operator is bitwise exclusive OR. This is XOR operator, that means exclusive OR operator. This can be represented with the cap symbol. The next operator is bitwise NOT operator. It can be represented with till character. This can also be known as bitwise negation. Next students, we have left shift operator. This can be represented with double less than symbol. The next operator is right shift operator, which can represent with these two greater than symbols. Like that we have 6 bitwise operators. And when we take bitwise AND operator, these bitwise AND operators take two numbers as operands, and then it perform AND between 2 bits on every operand. 2 bits of every operand. Next, bitwise OR. This operator also takes two numbers and performs OR operation on every bit of two numbers. Next, exclusive OR. It takes two numbers as operands and perform exclusive operator on every bit of two numbers. Next, bitwise NOT operator take one number as operand and it invert all the bits of that number. Invert means it makes 0 as 1 and 1 as a 0. Like that it invert the number. Next, left shift take two numbers as operands and it perform left shift, it shift left side bits of the number of one number by another number, and right shift, it takes two numbers and it perform right shift, that means it shifts the right bits of the number. Like that, here we have 6 bitwise operators. Now let us see this example. Here students, if you observe, uh, let us take one example here. You can see here, I want to explain you this, how these bitwise operators will perform bit level manipulations by taking a value equal to 5 and b value equal to 9. So whenever you want to perform bit level manipulation, first thing is we need to represent data in binary format. You know that the binary format is nothing but the representing the data in terms of zeros and ones, and the binary format can also be known as base 2 numbers. Whenever you want to get this binary equivalent of given decimal number, you know that this is the standard procedure what we have learned from our schooling. So now for example, my a value is 5 and the b value is 9. Now here what I have done, I calculate the binary equivalent of 5, that value is here 101. So this is the binary equivalent of 5. Next I calculate the binary equivalent of 9, that's value is 1001. 1001. So here second operand takes the 4 digits, that's why I want to add one more bit at left side to make it as a 4 binary digits. Now I want to perform binary manipulation by using bitwise operators on these two numbers. Now I want to perform bitwise AND operator, that is A and B. Now here let us see, if two bits are 1, then only resultant bit will be 1 in bitwise AND operator. Now the first, you can see this bit is known as least significant bit and this bit is known as most significant bit, and I start my operation from this side. So here the first bit of first operand is 1 and first bit of second operand is also 1. So if we perform AND operation between these two, the result will be 1. Next, the second bit of this is 0 and second bit of second operand is 0, the result is 0. Again here the third bit of this first operand is 1, but the third bit of second operand is 2, so these are two are the different bits, so again it is 0. Last bit, if you take the last bit, it is 0, here it is 1, 0 and 1 again 0. Now this is the A bitwise and B. Now this is the binary number, but I want to convert this binary to decimal, that is 0001. We know the standard formula to convert binary to decimal, that is 2 power 0, 2 power 1, 2 square, 2 cube. Here 2 power 0 indicates 1, so 1 into 1, that is 1. Now A bitwise and B equal to 1. Similarly, I want to do A bitwise or B. Again take the two numbers here. So these two numbers are like, the numbers are 101, again 01, the second number is 1001. Now I want to perform OR operator. So in bitwise OR operator, if any bit is 1 or both bits are 1, the resultant bit is 1. Here you can see the first bit in first number is 1, first bit in second number is 1, so the resultant bit is 1. And second bit in first number is 0, second bit in second number is 0, so the result is 0. Here first bit, third bit in first number is 1, third bit in second number is 0, so 1 or 0 1. Again here fourth bit, first number fourth bit is 0, second number fourth bit is 1, 0 or 1, again 1. Now it is 1101. Again double one zero one is the binary number of bitwise or A bitwise or B. Now I want to get what is the decimal equivalent. To get the decimal equivalent, again you follow the standard conversion, that is 2 power 0, 2 power 1, 2 square, 2 cube. Now 2 power 0 means 1, 1 into 1, 1 plus, next 2 power 1 0, 2 power 1 2, 2 into 0 0 plus, next 2 square 4, 4 into 1 4 plus, 2 cube 8, 8 into 1 8. Now sum all these things 13. Now A bitwise or B is 13. Now let us take the another operation, that is bitwise exclusive or B. A bitwise exclusive or B. Now again take these two numbers, what we have, A equal to 5 and B equal to 9. So let us take these two values and we will see how can we perform this exclusive OR operator. Now students, let me take again these two binary values. So the binary of the 5 is 0 1 0 1 and the binary equivalent of 9 is 1009. Now I want to perform A exclusive OR B. Now if you take the exclusive OR B operator, here the rule is if two bits are different, then the resultant bit is 1, otherwise the resultant bit is 0. Now let us consider this first bit. First bit is 1 and second bit is 1. Here two bits are same, so the result bit will be 0. Next, coming to second bit, 0 0. Again both bits are same, again the result is 0. Next, coming to third bit. Third bit, one bit is 0, another bit is 0, 1. So here two bits are different, so that the resultant bit is 1. Again coming to the fourth bit, two bits are different, again resultant bit is 1. Now this is the result of the A bitwise exclusive OR, that is 1100. Now I want to know what is the decimal equivalent value by using the standard formula, that is 2 power 0, 2 power 1, 2 square and 2 cube. Here 2 power 0 means 1, 1 into 0 0 plus 2 power 1 means 2, 2 into 0 2, 2 into 0 0 plus 2 square 4, 4 into 1 4 plus, next 2 cube 8, 8 into 1 8. Now 0 plus 0 plus 4 plus 8, finally it is a 12. This is the A bitwise exclusive B. And similarly we can perform bitwise NOT operator. So let us see how bitwise NOT operator works. So the bitwise NOT operator negate the bits, that means it invert the one bit from 0 to 1 or 1 to 0. So for example here, if you take a bit, if you take a number A, here A equal to 5, you know that already we have taken A equal to 5. Now for my convenient, I want to represent the number in 8 bits, so that the number becomes 0 0 0 0 and it is a 0 1 0 1 like that. So when I apply this bitwise NOT operator, our C compiler use 2's complement to represent that negative number. 2's complement. 2's complement means first we perform 1's complement by inverting 1 to 0, 0 to 1, and then we add 1 to the inverted result. Finally we get the 2's complement. Now when I perform the bitwise NOT operator on A, I will get minus 6. Next we have next operator, that is a left shift 2. Now my a value is what, students? 0 1 0 1. Now I want to perform two left shift operations. That means the left side means 2 bits. These 2 bits are shifted, and this 0 come to here, and this 1 is come to here, and these are all the zeros. Like that. So to perform efficiently, what I am doing here is I am taking this number in 8 bits representation. So it is what is the value of a? Here a value is 0 1 0 1. Now I am taking 0 0 0 0 0 1 and 0 1, like that I am taking. Now what I am doing here, I am performing the bitwise, these 2 bits. That means now this bit come here 0, this bit come here 0, this bit come here 0, like that. This bit come here, this bit come here, this is 1, this bit come here 0, this bit come here 1, and what happened here, finally we get the 0, like that. Now this is what happened. Now it is the value of a left shift 2. Now what happened when I perform these kind of bit level operation, finally these 2 will be added here, 2 zeros. Now the value becomes 20. The value becomes 20. The value becomes 20 here. Now these 2's will be added. Now here what happened, 2 bits will be added, 2 power 0, 2 power 1, 2 cube, 2 square, 2 cube, and 2 power 14, 2 power 4. 2 power 4 means here 16 plus 2 square means 4, 20. Like that we get a left shift 2, that is a 20. Next, a right shift 2. When we perform right shift, then these bits are moved to the right side. Right side bits will be skipped here. Now it is 1. We will in detail see in next slide how it works. Okay, bitwise left shift and right shift operator. So, and we have these kind of operators like this. And now let us consider, please take a notebook and practice these operations so that you can easily understand how bitwise operators works. Let us consider a value. Let us consider a equal to 10 and b equal to, that is 13. So now I want to perform a bitwise and b. So as I told you, whenever you want to perform bitwise operations, you have to convert data from decimal integer to binary integer. I explained the procedure how to convert that. So by converting those numbers, I will get, this is the binary equivalent of 10, this is the binary equivalent of 13. Okay, now I am doing the bitwise AND operator. Now when we are taking the bitwise AND operator, when 2 bits are ones, then only the resultant bit is 1, otherwise the resultant bit is 0. Let us take this example. So here the 0 and 1 both are different, so the result is 0. 1 0, so the result is 0. 0 1 0. 1 1, now this is 1. Now the result is 1000. This is a binary value, but I want to print it into the decimal value. To get the decimal equivalent of this, again convert this binary number to the decimal number by using the standard formula 2 power 0, 2 power 1, 2 square and 2 cube. Here 2 cube means it is only for this 2 cube only we have the 1, so that is 8. Now this is the result of the bitwise AND operator. Now let us try this bitwise OR operator on the same data, where a equal to 10 and b equal to 13. Now I am doing this bitwise OR operator here. What is the bitwise OR? If any bit is 1, the resultant bit is 1. Now here in this case this bit or 2 bits are different, 0 or 1, then the result is 1. 1 or 0, result is 1. 0 or 1, result is 1. But here 2 bits are 1, so here it is 0. Now when you take this, if any bit is 1, here it is also 1. If you take any bit like this, you can get the value of like this here, 0 2, then 4 ones is the result. Don't consider this value, so this is the 4 ones. 4 ones means what? It is 2 power 0, 2 power 1, 2 square, 2 cube. 2 power 0 means 1 into 1, 1 plus 2 power 1, 2 into 1, 2 plus 2 square. 2 square means students 4, 4 into 1, 4 plus 2 cube, 8, 8 into 1, 8. Then it is 8 plus 4, 12, this is 15. Now this is the value, resultant value is 15. This is the bitwise OR operator. Now we have bitwise exclusive OR operator. This is a bitwise XOR operator. In this case, if 2 bits are different, then only the resultant bit will be 1, otherwise the resultant bit will be 0. Let us take the example 0 1. So now the resultant bit is 1. 1 0, here both bits are different, so the result is 1. 0 1, again both bits are different, the result is 1. And 1 1, both bits are equivalent, so the result is 0. Now the value for this equivalent is 7. Like that exclusive OR operator works. Now let us take the bitwise NOT operator. So as I told you that the bitwise NOT operator just invert each and every bit from 0 to 1 or 1 to 0, and this is also known as bitwise complement. So if there is a 1, it becomes 0, if it is a 0, it becomes 1, 1 0 0 1, like that. Now if I take a equal to 9, then the result will be -6. Just it complements, it performs 2's complement on the number. Next we have the left shift operator. You practice by while I am explaining, please take a notebook and pen and practice it. So this is the way how the data will be stored in memory when we want to store some values. So for example, here if you take this 1 byte of data, in that this bit is known as least significant, this bit is known as most significant bit. So this is a left shift operation. Whenever you want to perform the left shift operation, the most significant bit will be moved. This was truncated to here, and now from this 6 bit becomes the 7th bit, 5th bit becomes the 6th bit, like that it moves. So for example, if you take a equal to 5, you know the 5 value. What is the value of 5 in binary? We know that 5 by 2, that is 1, 2 by 2, that is 0, 1 by 2, that is 1, that is 101. 101. Now for your convenience, you may add one more 0 here, that is the 4th bit. Now I want to perform a left shift 2. Now I want to perform 2 bits left shift on this number, that is 0101. Now what happened? These 2 bits will be moved here, and this 0 come here, this 1 come here, and here we have 2 0 bits. Like that we can get it. And this is a number when we are doing these operation, what happened? We get the 100, but here these 2 bits are moved here, and here we add 2 more zeros. Now what happened? 2 power 0, 2 power 1, 2 square, 2 cube, and 2 power 4, like that we will get. Okay, now when we perform this operation, you can get the result like there is a simple formula, that is left shift. For left shift operation, we can simply write a into 2 power bit. That means a into, for example, I want to do the 2 left shifts, then 2 power 2, that is 5 into 2 square, that is 5 into 4. Now result is 20. Now this is the operation we will get. Like that we can get the left shift operation. Similarly, we have a simple mathematical formula for right shift. You can observe here again 5 value is 2. Here take the 5 value. 5 value is 100 10 sorry 0101. We know this is the value of 5. So 0101, sorry, this is the value of 5. Here I want to perform 2 write bits, make this as the 8-bit representation for your convenience. Now what happened, these 2 bits are moved here 00010100. Like that it will happens. When it happens here, what happened here, we will get the division operation. So this is not, sorry student, this is not left shift, this is right shift. So when we take this value like 5, that is 0101, now I want to perform the right shift operation. These 2 bits are moved and here we get the 01 and the remaining right side bits are filled with 0. Now you can check the value, that is 2 power 0, that is 1. Now a right shift 2 equal to 1. That means here you can observe the formula, that is the formula is n by 2 power b. So here n value is 5. 5 by 2 power b means 2 square 4, 5 by 4 equal to 1. Like that we can perform the right shift operation. And this is the example program. If you observe here, very good program, you can execute this program here. So here if you want to find number of ones in a given number, you can convert it to the binary, and I want to check who wins the game. If number of ones are even, I want to print the RAM. If number of ones are odd, we print the win by money. For that purpose we read a number from the user. For that we take the scanf and printf statement. Now here what happened, I am calling a function here, ones count. Now the control goes to here and it perform the function execution and it find out whether the numbers are even or odd, it come here, and if it is even number it print this, otherwise if it is odd number it prints this. Already I think you know about if and else statement. This is the way how can we write the program using bitwise operators. Next here we have some self-assessment questions. By doing this assessment we can understand whether we understand this concept or not. So first let us check what is the output of the program. Here you see students, int a equal to 2 and I want to perform a left shift 1. Here what is the a value? Here a value equal to 2. And what is the binary equivalent of 2 students? 0 1 0. Now I am doing a left shift 1, that means 1 bit will be removed. Now it is 1 0 0. 1 0 0 means what is this value? 4. So this is the answer for that. Now let us take a is 2 and b is 5. A is 2 means again 0 1 0 and 5 means here 1 0 1. This is the binary equivalent. Now I want to do a c equal to a bitwise and b. Now c equal to and means bitwise and means if both bits are 1 then only resultant bit is 1, otherwise the resultant bit is 0. Now perform the bitwise and 0 and 1 0, 1 and 0 0, 0 and 1 1 0. So the result is the first C will be 0. Next A exclusive or B. A exclusive or B means again take these two numbers 0 1 0 and 1 0 1. Now perform the exclusive or. The exclusive or operation takes 2 bits and if 2 bits are different then it will give 1, otherwise it gives 0. So here if you observe, first 2 bits are different, so 1, again second 2 bits are different, 1, 2 bits are also different, again 1. Now the result is 7. Now what will be the output? 0, 7. Now this is the answer. Okay, so like that you can take some examples and practice this, and some of the terminal questions I want to give you. Just take these questions and prepare the material for these questions. List out the various bitwise operators. You know what are the bitwise operators? 6 operators are there. What are those? Bitwise and, bitwise or, bitwise not, bitwise exclusive or, and left shift and right shift operation. Why should we use bitwise operators? So we know that to perform bit level manipulation on binary data, we perform the bitwise operator. We use the bitwise operators. Next, develop a C program to swap two numbers using exclusive OR operator. So if you take a two numbers A and B, if you perform recursively exclusive OR operator like this, A equal to A exclusive OR B, B equal to A exclusive OR B, again A equal to A exclusive OR B, so we can get the values from A to B and B to A. So that is the power of the bitwise operators. So at the end of the section I would like to say these bitwise operators are very useful whenever we want to perform bit level manipulations on binary data. So the bitwise operators, whenever you want to work with bitwise operators, you must know how to convert a decimal number to the binary number, and these are the references. We can follow these books to understand, to prepare some material, or to exercise some problems, all those things, and you can use these links also. I hope students everyone understood it. Thank you very much.